All right. Hi everyone. This is the tutorial 4 for term 2 of microeconomics. Hope this helps. This is quite early for me, so I'm actually doing this one at a good time. Hopefully I'll be able to go through the A questions and the B questions and all that. But yeah, let's get started then. All right, so first of all, if you want the quick answer for A, it's going to be C and B. Okay. Let me explain why, first of all. So, what we crucially are told in question 1 of A is that Dennis and Ed would have the same homothetic preferences, okay, but Dennis has higher total budget, okay? Now, this isn't even relevant in this case, because if we remember, the higher budget doesn't really matter, because this is the Pash and Lapres, the Pash and Lapres index are the ratio of prices in this case. So if prices have the same ratios towards them, budget doesn't really matter too much in this case. It's not particularly relevant. So in this case, the indexes for both, so LD and LE, and PD and PE, are going to be the same. Okay, so we can say that the Lapres indexes are equal and the Pash indexes are equal. This rules out A and B, okay, because we know that they are equal to each other, okay? So that just kicks that right the gate. Now here we're given Lapres and Pash compared to each other. Now this one says Lapres is above Pash, and this one says Lapres is below Pash. Now if you remember from week 6, I think I can open and just show you as well. If you remember from week 6 here, at the bottom, that is not the correct week. Is it 5? I think it's 5. It might be 5. I might have skipped it. Yep, here it is. We know that the Pash index must be smaller than or equal to T, which must be also smaller than or equal to L. So because this is the case, Lapres has to be larger than Pash, which means that, yeah. Oh dear. Wait, did I do it wrong? Yeah, hold on. This has to be the other way. Greater than or equal to. So the only valid one here, okay, because Lapres is larger than Pash, okay, and because LD is equal to LE and PD is equal to PE, only this one is correct. Okay, so C is correct in this case. Okay, now on to number 2. So the consumer with an endowment of a certain good is a net seller of that good. Its price rises and it is a normal good. Which of the following is true? Now, if you remember what we had from endowments, okay, and if you remember what warp is, actually, let me just go through warp first of all. Warp, fundamentally, is essentially if I had an option open before and I didn't take it, okay, if it is available to me again, I can't pick that option because I've already showed to you that, oh, I don't want that option. So if it's available again, why would I pick it? These two don't violate it, more or less of the good, because I can still be on the budget set and still do that. But, and this also means none of the above constitute a violation of warp. The only one that constitutes a violation is if we become a net buyer. Because all those buyer options were open to us before, okay? We had the option of buying that good instead of selling it. But the fact that we did sell it before shows that we're not going to be buying it in the next bit, because we could have been buying it. We could have very easily, because we had an endowment of it, bought that good, but we didn't, okay? So this is a violation of warp, because we could have sold our good and bought some stuff, but we chose not to. So we're not going to do it in a price rise either. Regardless, that is the case. Okay, so part B, a lot longer, unsurprisingly. We're given 2 sort of long questions. This one sort of has 5 parts to it, if you sort of break everything down, and this one has 3 parts to it, okay? So I'll be going through the first one and then the second one. We also have this. It's listed here as figure 1, even though it's figure 4.1, but we'll just ignore that. Oh, it's because it's in the 4th tutorial and it's figure 1. I see. Is this still recording? Sometimes it freezes. Okay, hopefully this will be alright. But still, let's get into it. So, first of all, we're given individuals in a population with total budgets of Y facing prices of P have been captured by this indirect utility function, and we're given this here. Let me zoom in just so you guys can see it. I think that's a bit too far. That's good. Hold on, I should probably turn off some more text on this as well, just to make sure you guys can see it properly. Okay, so we have this indirect utility function, okay, where we have BP and AP, which are functions of prices, respectively. So now we have to use Roy's identity to show that Marshallian demand functions obey this rule, okay, where the budget share, denoted by W, is equal to price times the Marshallian demand over Y, which itself is equal to these two expressions over here. Now, I do eventually get this, and I will show you how. Now, Roy's identity, okay, if we sort of look back at what Roy's identity was, which is in 3, I think it's in 4. It's all the way back here in consumer choice. If we look back at Roy's identity, hold on, let me zoom out and just sort of show you. Roy's identity, voila, we see that the differential of the, hold on, I'm going to zoom in on this just so you guys can absolutely see it. The partial differential of the indirect utility function with respect to price, and the negative version of this, mind you, divided by the partial differential of the indirect utility function with respect to income is equal to the Marshallian demand. Okay, we know that. That is the case. Okay, remember it is the negative specifically in this case. Okay, so in this case, all right, it's going to be, yeah. So then we divide it, it's a negative, yeah. Yeah. Okay, I think I forgot to put the negative on, that was probably why. 1 second, I think I've made a fuck up here. Just give me 1 second to revise it. There we are, sorry. I messed up on the calculations there. So, I forgot to put a negative sign in front of it. You got to remember the negative sign. But regardless, okay, what we're going to do is we're going to take this indirect utility function and we're going to partially derive it with respect to P and with respect to Y. This gives us our Marshallian demand. So that's all cool, okay? Now, you can start by deriving with respect to P. You should get this, okay, which is the partial derivative of B with respect to P times ln of Y over AP, because, of course, you're going to combine these at some point. So that's sort of the case. And then you're also doing it for the P in these functions as well. So you get that overall. You probably use a derivative calculator if you're having some trouble with this, but this is at least what I got, okay? Then we also get the partial derivative for income out of all this. Of course, only ln Y contains income, so we just derive that, and we get BP over Y, okay? Now, if we divide these, making sure the negative side is at the front, because as we saw from this, the negative side has to be at the front, okay? Putting the negative side at the front, we get this expression, okay? Now, we are also told here that so this is essentially the Marshallian demand, okay? So, we're going to times this by P, and we're going to divide by Y, and this is going to give us budget share, okay? Now, if we do that, if we divide by Y, this removes the Y's from the top, and we times by P, we're going to basically put P in place of Y, in this case. And in this case, that gives us this expression here, this lovely expression, which, as you see, is equal to sort of what we've got here, okay? Same expression, okay? So we've got it, all right? If you feel the need to pause and look through this in more detail, feel free. I'm also going to include this in the description as well, so in case you need to see it there. But here it is, okay? Now for B. What sort of preferences are these if BP is independent of P? Discuss the role of BP in determining the shape of the angle curves. Now, we're going to consider the angle curves here as specifically budget share, okay? Angle curves are sort of just the budget share as our consumption increases, okay? So when we thinking about it, we want to look at sort of this function over here. Now, BP here is specifically going to matter when we're coming to the gradient of sort of our budget of our angle curve, because you see over here we've just got a constant term here. You've got the partial derivative, which is AP with respect to P, which is going to be in this case a constant, okay, or at least in terms of prices, which itself will be a constant. And then here we've got BP, okay, which is going to determine our constant on ln of Y, okay. So it's sort of going to act as the slope of our angle curve. Now, because BP is independent of prices in this case, BP is 0, okay? A function that is dependent on prices, not being dependent on prices anymore, is just going to have a value of 0, okay? That's simply what it's going to be. Which means, if the value of BP is equal to 0, this entire term on the right just disappears, and we're left with this, okay? So we're just going to end up with a constant angle curve. It's essentially just going to be flat, okay? So if we have a flat angle curve, nothing's really going to happen in that case. So we can basically say that BP determines the sort of slope of the angle curve. So, the larger BP gets, as you can sort of see here, the more downward sloping it's going to be. And then if we have a smaller BP, it's going to be more upward sloping. So that's sort of its relevancy in that case. Okay. Now we're given a question, find the form of the expenditure function and show a true CONUS cost of living index has the form this. Now, if you remember from, I think, the last tutorial, you can get an expenditure function quite easily by just using the indirect utility function. Here, we're simply going to replace, I believe it's y? Yeah, we're going to replace y with our expenditure function. This sort of makes sense. Expenditure functions determine how much we're consuming. So, wait, no. The expenditure functions determine how much we're spending. So it's not inconceivable to put that in place of y in this case. You sort of just remember it, they're the inverses of each other in their first arguments. So if I was doing if I was doing it in the reverse, I would replace v with the indirect utility function, and if I was doing it for this one, in this case, I'm replacing y with the expenditure function. So that's what we do. So we put that in here. And we just want to rearrange, essentially, for the expenditure function. Pretty easy. I don't think I need to take you through this. All it takes is just sort of rearranging and then doing a sort of e to the power operation to sort of bump it up. And what you get is this lovely expression, which is e to the power of v over bp times our ap. It's because adding these two, okay, it's essentially creating two separate e functions here. And e to the power of ln AP is just going to cancel because it's e and ln, so it just ends up with AP. You guys did A-level maths, or, well, actually, I don't actually know exactly what you did. You did maths at some point, so you probably know how to do this. So I'm probably not going to run through it too much. But regardless, okay, so now moving on. We now know that this is the expenditure function. Now, the CONUS cost of living index, I think this is also in 5? Who knows at this rate? Yes. Okay, so the true CONUS cost of living index, as you can sort of see in 5, where is it? Oh, it's here. It is the two expenditure functions, just with two different prices. Now, it's given us two different prices here. It's given us P1 and P0. So all we're going to do, really, is insert P1 and P0 and divide them, okay? And this is pretty easy. The E functions get divided by each other, which means, their exponents get minused, and we shift that over to the right. We get this lovely expression, which is equal to this one. Huzzah, we've done it. Yeah, it's all good. So now, what happens when BP is independent of P in this case? Well, you see here that BP is now part of the exponent. Now, if BP is independent of prices, again, we know it equals 0. So this entire term is going to be 0, meaning this entire exponent is going to equal 0, meaning it's going to be e to the power of 0, meaning e is just going to equal 1. So it's just going to be AP1 over AP0, which is just the ratio of prices in this case. So we now know that if BP is equal to 0, and we're relating it to angle curves, so if our angle curve is flat, okay, our budget share never really changes, okay? It's sort of like if I always spent... It's sort of like, have you ever heard of those people, okay, I'm just going to go on. Have you ever heard of those people who give 10% of their income, no matter what their income is, to charity, okay? That would sort of be what we're doing here, okay? It's always going to be 10% of our budget, regardless of our income level, okay? That's sort of what we're doing here when BP equals 0, okay? So it's going to be a flat budget curve, okay? And we now know that when we have a flat budget curve, e.g. BP is equal to 0, we know that the true cost of living index is the ratio of those prices, okay? It's the ratio of the prices, just to each other. That's all it's going to be. It's not dependent on V, because we've cancelled out V by making BP equal 0. So it's not dependent on the utility level, it's just dependent on prices. Okay, that is that. Now for 3, figure 1, ta-da, shows an estimated relationship between the budget share for fuel and the logarithm of total expenditure. Now, logarithm of total expenditure could be percentage of total expenditure. You can still think of it like that, the percentage of my total expenditure. Actually, maybe not. Percentage change in total expenditure. Hold on. I'm going to change that. And total, yeah, and total household expenditure. Let's just delete that. Okay, so we have a logarithmic, at least, relationship here. So suppose the price of fuel rises faster than other goods, okay? So let's say we're in a massive inflation period. I know, completely unrealistic, but go with me. We're in a massive inflation period, and essentially the price of fuel is rising higher than all the other things. Now, other things being equal, okay, would you expect the true cost of living to be higher for more or less well-off households? Well, if we look here, our angle curve is downward sloping. So what do we know about downward sloping angle curves? Well, downward sloping angle curves are necessities, okay? I sound so bitchy. They're necessities. Oh, fucking hell. So if it's a necessity, okay, it's going to affect poorer households more, okay? Think about it like a rich household, okay, when the price of food goes up, they're not really going to be concerned because that's a tiny part of their income. And if it goes up by like, I don't know, 50 quid, like that's not really something that's going to bother them too much. That's not a big percentage of their income. Whereas a poorer household who is getting by paycheck to paycheck, if the price of food goes up, that's a really big problem because like now suddenly your food costs, 50 quid more per week, and that's a massive percentage of your income. So when fuel goes up, and fuel is a necessity, that's going to hit poorer households harder because it's a bigger percentage of their income. So yes, it's going to expect, we're going to expect the true cost of living to be higher for less well-off households in this case. Okay, so that's that. Now on to question 2. So this one is John has 24 hours in his day, lucky John, which he can devote to working and earning income or to leisure. Ugh. This is wage labor capitalism, people. Don't try to do it. It kills you. The wage rate is W, and he has no other source of income. So he consumes R, which is equal to his wage times his labor. So this is assuming his sort of like income. If he works L hours. His utility function is given in terms of, what is that? So his consumption and his hours that he's working. And this is his utility function. Where John devotes hours, which is equal to T, which is 24, minus L. So the hours of leisure in his day is equal to 24 minus the amount of hours he's working, excluding transport and everything like that. Now we want to calculate his labour supply curve. Now how do we do that? Well, a labour supply curve would say, okay, labour supply given other things. Now we already have a similar thing here where we have our budget constraint. Where is our budget constraint? Where did it go? I swear I saw this at some point. Where is it? Oh yeah, fuck. Yeah, okay. We can sort of use a budget constraint here. Okay, yeah, sorry, I got this and then I forgot where I got it. We can insert in place of L here the sort of 24 minus hours in this case, because L is going to be equal to T minus H in this case. So we insert this into here, and we get our budget constraint, which is R. I'm not entirely sure what R. Let's just say it's R for now. R is equal to W times 24 minus H. That's our budget sort of set. If you want to think of it like that, that's how much we can actually get, depending on how many hours of leisure we have, how many hours we work, regardless. Okay, so that's our budget set. Now, if we want to figure out our utility and sort of where it meets our budget set, we need to think of this as sort of like an indifference curve budget problem, if you want to think of it like that. So if you want to think of the utility function as like preference curves that we need to make sure are tangent, and the budget set is something that we have to make sure it's a tangent to, we're going to think of it like that. And then hopefully, from the end of that, we'll get our labour supply. We do. Go with me here. So, first of all, let's look at our utility function. Okay, our utility function is going to be how we get our preferences. Now, what do we know about preferences? Well, we kind of need to know its slope, right? We need to know the MRS, okay? And how do we calculate that MRS? Well, if you remember, MRS is going to be the marginal utilities of the two goods divided by each other. And we can get that by sort of doing partial differentials of our utility function. I'm not going to go through the entire differentiation, but if you want to look at it, here it is. Again, notes in the description. And we get our partial, dear Lord, go away. We get our partial differentials, okay? And then we get our MRS, which should be R over H squared. That's all good. Now, we know that the MRS of our preference curves have to be equal to the MRS of our budget set. Now, what's the MRS of our budget set? Well, if we look here, it's just W, right? That's our slope, okay? Because it's going to be 24W minus WH, and H is sort of how it varies, okay? We can think of it as sort of like RH in this case. So, in this case, R over H squared is going to be equal to W, which we rearrange into sort of R squared equals WH squared, or R is equal to root of WH, which is sort of what I use here. So we can insert this finding for R into our budget set. So we now have root W times H is equal to W24 minus H. And if we rearrange this, we get an expression for H in terms of W. Okay, so this gives us hours in terms of W now. Now that we've got hours, we can now insert this into our previous function, because now we have hours, we know the amount of hours in terms of wage, and we know T, which is equal to 24, but we don't know L. We can now insert this, and we get our labor supply function. Okay, so L is going to be equal to T minus H, in this case. Okay, and if we insert H, we insert our function there, we rearrange, and we get L is equal to 24, bracket 1 over 1 root W. And that is our labor supply function. Okay, we now know that labor supply is going to vary based on the wage I'm offered. Lovely. I love that. I don't love it, but I got the answer, so at least that's good. Calculate the elasticity of his supply with respect to the wage. Is the income substitution effect dominant? Income or substitution effect dominant? So if you remember what the elasticity of labor supply is, it's sort of the percentage change in labor supply over the percentage change in the wage, which is essentially the derivative of W with respect to W and the derivative of L with respect to L. Now you can rearrange this, thankfully, into W over L times the derivative of L with respect to Y. Okay? So basically, what you get from that is this calculation here. So we're going to do the derivative first, and that gives us minus 12 over 1, minus 12 over root W bracket root W plus 1, close bracket, squared. That's what we get. Again, use a derivative calculator, I don't give a shit. But then if we sort of just calculate it, we now get this expression here, which is going to be negative a half root W over 1 plus root W. That is our labor supply elasticity. Now this is negative here, right? So now we know that these two effects are going to be going inverse to each other. My labor supply is going to increase when my, my labor supply is going to be increasing when my wage decreases. Yeah, exactly. Sorry. My labor supply increases when my wage decreases because I need to get more of that money. And my labor supply decreases when my wage increases, okay? So these are opposite to each other, okay? Now, in this case, okay, this is the income effect dominating. So income effect is essentially, I'm focusing on the income I'm getting, and I get more if I get more income. So if my wage is going to decline, I'm going to work more because I want that income, right? But if my wage suddenly goes up, then I don't have to work as much to maintain the amount of income I've already got. So I'm going to take some time off, right? Income effects work in opposite directions, essentially. So the substitution effect is not dominating, the income effect is dominant here, okay? So that's the case, okay? Now, final bit, we now have John having a non-labour income of plus M, okay? Now, what we're going to do is we're going to add that to our budget constraint up here. It's going to be sort of, we have our total income, so R is income, shocking. R is income, so we're now going to add M to it, okay? Now, if we perform, you can basically perform the same exact thing again. You can basically do the MRS is still going to apply, so we can still use that. We reinsert it, we get an expression for H, we get an expression for L. Okay, I've sort of gone through it in very short way here. Okay, and what we do is we essentially get the same expression, but the top is now going to minus m over 24 root w. Okay, so it's going to be smaller than before. Our labour supply is going to be a lot smaller than if we didn't have non-labour income, which makes sense, right? I'm not going to work more if I get money from not labour, right? If I get 500 quid a month and I don't work, then why would I work? I hope my parents aren't watching this. But regardless, okay, yeah, essentially our labour supply is going to be smaller, okay? Our labour supply decision is going to be just generally, yeah, smaller. And the shape of the labour supply curve, if you actually type this in, actually this is quite interesting, okay? So what I'm going to do here is I'm going to open up GeoGebra, and I hope to God it works. Yeah, how does that change the shape of his labour supply curve? Now, bring in Notion. So we know our labour supply curve, okay? Our first one was L double, it's just that, okay? So we're going to do, well actually let's do it, let's set M first of all, and then we're going to do Y, which is L in this case, but ignore me. 24 over 1 plus root X. So this was our starting one, okay? You see it's just a slow go down from 24, okay? Now, if I add in my term, in this case, again, this is exactly the same, so just think of it like that. If I add in my term here, hold on, let me just make sure the slider actually works. I just want to give you guys a bit more intuition about what it actually will look like. Okay, so as you can see, when m equals 0, I have my starter 1, but as I slowly increase m, the numerator is going to get smaller, so it's going to start from a lower point, okay? And eventually, you can sort of start to see a shape appearing where it rapidly starts up at the top, plateaus, and then drops, okay? So if you want to sort of think about it, this would be the point, or at least the hours I work, where I have the optimal labour supply, which I guess companies could use to like sort of think about it. But you can sort of see it goes from this spike upwards to a spike downwards to a spike upwards, and then down gradually as I sort of move M around. Hopefully that's helpful. And I've given the example here. This is for 9.4. Yeah, so this is essentially going to be the labour supply curve in that case. And as you can see, there's a point where I don't even work at all in this case. So I just won't do anything in this case as my yeah. This is wage essentially. So this is the wage that maximizes my labour supply. But at this point, when I have my wage in between 0 and, I don't know, 0.16, I don't need to work, basically, if my M is that high. So hooray. Anyway, that is all for today, I think. Let me just move things back. Yeah, I think that's everything. Hopefully that was helpful for you guys. I know some people had some trouble with this, so I thought, like, at least give my 2 cents about it. But yeah. Do let me know if anything was unclear. I'm going to put these in the description afterwards. And yeah, have a nice day, I guess. Bye.